Welcome to Learn Yourself. Today we are going to solve exercise for the chapter Atoms and Molecules. This chapter is under CBSE Std-9 syllabus. These questions are from page 43. Our first question is 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. So here this is a gram of sample. This is total gram of sample which we have. And it contains oxygen and boron. So there are two constituents present in this sample. And by weight, boron is 0.096 gram and oxygen is 0.144 gram. Now we have to find out the percentage composition. How to find out percentage composition? We have this mass of sample. So in this, that if 0.24 gram of sample is 100% of the sample, then if we have 0.144 gram of oxygen into this, then it is of what percentage of this sample? Then by unitary method, 100 into 0.144 divided by 0.24. This is our total sample. So the answer is 60. So 60% of oxygen present in this sample. So how we have found out this? In this total sample. This total sample is 100% because that is all we have. So that is 100% of the sample. Now from this we have this much amount of oxygen. So how many percentage of oxygen is there? If this much is 100, then for this, what is the percentage? So 60% oxygen is present in this. Now we can write directly that if this is 60%, then remaining 40% is boron because percentage is always 100. So if this is 60, then remaining 40 is for boron. But we have to calculate and show. So the same way, what is the total sample weight? 24 gram, and that is 100%. So what is the weight of boron? This. So 0.096 gram is weight of boron. So this will consume how much percentage of this compound? So 100 into 0.096 divided by 0.24. So it is 40% boron. So this is how we can find out the percentage composition for any particular molecule. In this, there are chances that there are 3 atoms or 4 atoms. So if there are 3 atoms, then similarly we have to calculate for all the 3 atoms. Our next question is, when 3 gram of carbon is burnt in 8 gram of oxygen, 11 gram of carbon dioxide is produced. So carbon plus oxygen will give us carbon dioxide, and 3 gram of carbon is burnt in 8 gram of oxygen and we will get 11 gram of carbon dioxide is produced. What mass of carbon dioxide is formed? So this we have to find out in second situation. When 3 gram of carbon is burnt in 50 gram of oxygen. So here we have made this 50. This is remain same and this we have made 50 of oxygen. And which law will govern your answer, or which law will help you to get through this answer? So here 3 gram of carbon atom is reacting with 8 gram of oxygen and we will get here 11 gram of carbon dioxide. Now, if we are taking 3 gram of carbon and we are taking 50 gram of oxygen, then how much carbon dioxide will be produced? Now here, if we are taking any one particular atom more, that doesn't mean our yield will be more as well, because here our carbon atom is only 3 gram. So it requires only 8 gram of oxygen to form carbon dioxide. If only one element you are taking in high proportion, that doesn't mean our yield will be high, because it has to combine in a ratio of 1:2. If this is 6, that doesn't mean this will be also more. We have carbon in limited amount, that is only 3 gram. So we required here only 8 gram of oxygen, and if it is more, then it will remain as it is. It will remain unreacted. So for this situation, 50 minus 8, so 42 gram of oxygen will remain unreacted, or whatever product we will get here is 11 gram of carbon dioxide plus 42 gram of oxygen will be there, because this 50 will not be used completely. We required only 8. To this constant proportion of carbon dioxide, for this constant proportion, we required only this much gram of oxygen for 3 gram of carbon. For 3 gram of carbon, we required only 8 gram of oxygen. And if we have only 8 gram of oxygen, then we required only 3 gram of carbon. If we have taken here carbon more and oxygen is 8, for example, this is separate situation, that in which carbon and oxygen we have taken here 5 carbon, but we have taken here 8 oxygen, then also we will get gram of carbon dioxide, because if only one element you are taking more, that doesn't mean your yield will be high. Your yield will be as equal to your composition of the molecule or the composition of a molecular formula. That means which law is used here? The law of constant proportion, that this much amount of carbon will react with this much amount of oxygen. If you will make one element high in amount, then our yield will not become high. It is depending upon both the element. So which law is used here? The law of constant proportion. If you want more yield, then we have to simultaneously make both the amount high. Only one amount will not be useful to make yield high. Third question, what are the polyatomic ions? The name itself suggests that polyatomic. So ions which are formed from 2 or more atoms are known as polyatomic ions. Now for example, we can write SO4 minus 2. Sulfur and oxygen both are there, and how many total atoms are there? 5 atoms. 4 atoms of oxygen and 1 atom of sulfur. So total 5 atoms are there. This is sulfate. Then nitrate, NO3 minus, this is nitrate ion. Then SO3 minus 2, so this is sulfite ion. Then carbonate, CO3 minus 2. So in this 1 atom of carbon and 3 atom of oxygen, this is carbonate. So all these are example of polyatomic ions. Now in fourth question we have to write chemical formula. So magnesium chloride, so this is magnesium and this is chlorine. This is 2 and this is 1. So via crisscross we will get MgCl2. Then calcium oxide. So calcium and oxide. Calcium is 2, oxygen is also 2. So via crisscross both are same. So we will write CaO. If both valency are same, we are not mentioning it. So the molecular formula is calcium oxide. Then copper nitrate, CuNO3, copper. So here we are taking copper's valency 2 and nitrate is 1. So our molecular formula is CuNO3 twice. We have to make a bracket because this is polyatomic ion. So this 2 is going with both nitrogen and oxygen. So we have to write like this, copper nitrate, CuNO3 twice. Now aluminium chloride. So aluminium is Al and this is Cl. Now aluminium's valency is 3 whereas chlorine is 1. So via crisscross we will get AlCl3. Now calcium carbonate. So this is easy, CaCO3. Both's valency is 2. So we are not mentioning it and the molecular formula will be CaCO3. Our next question is, write the name of the element present in this particular compound. So first they have given the name of the compound, so we have to write molecular formula, or we should know the molecular formula and then we will write a element or atoms present into that. So quicklime. Quicklime molecular formula is CaCO3, calcium carbonate. So how many elements are present into this CaCO3? Calcium, then carbon and oxygen. So it is calcium, then carbon and oxygen is present in this. Hydrogen bromide. Formula is HBr. So in this, how many elements are there? Hydrogen and bromine. Baking powder. What is the molecular formula of baking powder? NaHCO3. Now how many elements are present in this? Sodium, hydrogen, carbon and oxygen. So it is sodium, hydrogen, carbon and oxygen. So these 4 elements are present in this. Potassium sulphate. So it is K2SO4. This is a compound. So in this potassium, sulfur and oxygen is present. So first is potassium, then sulfur and then oxygen. So these are the name of the elements present in this compound. Our next question is, calculate the molar mass. What is the meaning of molar mass? Molar mass is molecular mass, molecular weight. So here C2H2, ethylene's molecular mass, molar mass we have to find out. So in this 2 atoms of carbon and 2 atoms of hydrogen is present. So 2 into 12 plus 2 into 1. So it is 24 plus 2. So 26 is the molar mass of ethylene. Then S8. This is sulfur's molecule. Sulfur's atomicity is 8. In one molecule of sulfur there are 8 atoms. So here 8 into sulfur. Now at the place of S we are going to write its molecular weight, that is 32. So it is 32. So 32 into 8. 256 is molar mass for sulfur molecule. Now P4. Phosphorus atomicity is 4. That means in one molecule of phosphorus there are 4 atoms of phosphorus. So 4 into P. So 4 into 31. 124 is the molar mass for phosphorus. Now HCl. So in this 1 atom of hydrogen and 1 atom of Cl is there. So 1 into 1 plus 1 into 35.5. So the answer is 1 plus 35.5 equals to 36.5 is the molar mass for HCl. Now HNO3. This is nitric acid. So 1 hydrogen plus 1 into 14. This is for nitrogen, plus 3 into 16. This is for oxygen. 3 into 16. So it is 1 plus 14 plus 48. And the answer is 63. So this 63 is molar mass for HNO3 and that is nitric acid. Our next question is, what is the mass of, and we have to calculate for this following compound. So first is 1 mole of nitrogen atom. Now we have to find out the mass for 1 mole of nitrogen atom. In mole concept video we have studied that a mass of 1 mole of substance is equals to its molar mass. Now what is the meaning of molar mass? Is molecular mass or atomic mass. So 1 mole of nitrogen atom, it's already 1 mole. So nitrogen's atomic mass is 40. So if 1 mole of nitrogen atom is there, then its weight is 40, because 1 mole equals to molar mass. One more example. Potassium. Its molar mass is 39. So if 1 mole of potassium atoms are there, what will be its weight? Equals to its molar mass. So it is 39. So any element will be there. If 1 mole of element or 1 mole of that particular substance is there, its weight is equals to its molar mass. So atom is equal to its atomic mass or molecular mass. Second is 4 moles of aluminium atom. Now aluminium's molar mass is 27. So 1 mole of aluminium's 1 mole of aluminium atom has mass of equals to its molar mass. So it is 27. Now 4 mole of aluminium atom has mass equals to 4 into 27. 108 gram weight. So we need to remember here 1 mole of particular element equals to its molar mass. The next question is, we have to find mass of 10 mole of sodium sulphate. Till now we have found out weight for nitrogen atom and aluminium atom. Their molar mass we have directly taken into consideration. Here we have a molecule. So we have to count here molecular weight for this molecule. So sodium sulphite is Na is sodium, sulphite is SO3. Now their valency is 1 and 2. So the molecular formula will be Na2SO3. This will be the molecular formula of sodium sulphite. Now we have to find out the molecular weight of this. So it is Na2SO3. So 2 atoms of sodium plus 1 atom of sulfur plus 3 atoms of oxygen. Now 2 into sodium's atomic weight, that is 23, 1 into sulfur's atomic weight, that is 32, plus 3 into oxygen's atomic weight, that is 60. So our answer is 126 gram is molecular weight for this. Now 1 mole of sodium sulphite has how much weight? Equals to its molar mass. Then 10 mole of sodium sulphite has how much weight? 1260 gram. So this is how we can calculate for any compound. Next question is, we have to convert this into mole. First is 12 gram of oxygen gas. So here we cannot take oxygen atom. We have to take oxygen molecule, because in the gas oxygen remain present in molecular form. So our one formula is there, that number of moles equals to given mass divided by molar mass. This formula we have already studied earlier. This is number of moles. Given mass means whatever substance mass we got it from the question is given mass. Molar mass is molecular mass, atomic weight or molecular weight. So M equals to given mass is 12 divided by molar mass. Now if they have asked here that 12 gram of oxygen atom, that we could have take here 16. But here it is oxygen gas. So we have to count it for O2. So it is 2 into 16. So it is 32. So molar mass of oxygen gas is 32. So it's 32. 0.375. So number of moles for 12 gram of oxygen gas is 0.375. Now next, 20 gram of H2O. Now 20 gram of H2O. What is the molecular mass of H2O? So 2 into 1 plus 1 into O. O is oxygen. So here we are taking 16. So the answer is 2 plus 16 equals to 18. So 18 is molecular weight for water. So here N equals to number of moles given mass divided by molar mass. What is the given mass? 20 gram. 20 gram is given mass. So it is 20 divided by 80. So the answer is 1.11. So 1.11 mole of water has how much weight? 20 gram. Now third is 22 gram of CO2. So our formula is number of mole equals to given mass divided by molar mass. So what is the given mass? 22 gram. Now molar mass. For molar mass we have to find out molecular weight for carbon dioxide. So CO2. So carbon is 12 plus 2 into 16. So 12 plus 32 equals to 44 gram is the molecular weight for carbon dioxide. So here we are going to write 44. So it is 1 divided by 2 equals to 0.5 mole. So carbon dioxide's 0.5 mole has 22 gram of weight. Ninth question. What is the mass of 0.2 mole of oxygen atom? In previous question we have found out number of moles for given mass. Here we have to do exactly opposite, that they have given us a mole and we have to find out the mass for the same. So we are using the same formula, N equals to given mass divided by molar mass. Now here we have this, but we have to find out the given mass. So we will reframe this formula and make it like given mass equals to number of moles into molar mass. This is number of moles. So when this will change its sign, it will go to numerator. So number of mole into molar mass equals to given mass. Now number of mole is 0.2. Now molar mass. Molar mass for oxygen atoms. This is important. Atom. So here we can take 16. If they have asked for oxygen gas, then we would have taken here 32. Now 16 into 2. So 32 and point. So 3.2. Now this is mass. So we are going to write here gram. Second is we have to find out mass for 0.5 mole of water molecule. So here N equals to given mass divided by molar mass. Now here we have mole, we have molar mass. We are going to find out this. And we require information for given mass. So given mass equals to number of mole into molar mass. So how many number of moles are there? 0.5. And molecular weight for H2O molecule, one molecule, it is 18. H2O, so 2 into 1 plus 16 into 1. This is for oxygen, this is for hydrogen. So 16 plus 2, it is 18. So that is how we calculated molecular weight for water. So 18 into 5, it is going to be 9.0 gram. So 0.5 mole of water has 9 gram weight. 10th question. Calculate the number of molecules of S8 present in 16 gram of solid sulfur. Here, first S8. So we have to find out molecular weight of sulfur molecule. S8, that means 8 into sulfur. This is one sulfur. One sulfur's atomic weight is 32. Sulfur's atomic weight is 32. So it is going to be 8 into 32 equals to 256 gram. So one molecule of sulfur weighs this much gram. Now calculate the number of molecules of S8 present in 16 gram of solid sulfur. Now we have weight, that is 16 gram. Now in this, how many molecules of S8 present, that we have to find out. So first, we know that 1 mole of S8 weighs how much? This much, because this is its molar mass. So it is 256 gram. Now this equals to how many molecules? Earlier we have studied that in 1 mole of substance there are 6.023 10 raised to 23 molecules will be there for any substance. So this will remain constant for any substance, that 1 mole of substance equals to its molar mass equals to 6.023 10 raised to 23 molecules or atom. What is this number? This number is Avogadro's number. Now we have this many molecules in this much gram, but we require molecules in 16 gram. So from here we can calculate that in 256 gram this many molecules are there. Then in 16 gram how many molecules of sulfur will present? So 6.023 10 raised to 23 into 16 divided by 256. So the answer is 0.625 10 raised to 22 will be the answer. So in 16 gram of sulfur there will be 0.625 raised to 10 raised to 22 molecules will be present. How we have done this? First we found out the molecular weight of sulfur. One molecule weighs this much. Then 1 mole of sulfur equals to its molar mass equals to Avogadro number. This many molecules are remain present in 1 mole of substance. So in this much weight, this many molecules are there. Then in given mass, so this is given mass. Then in given mass, how many molecules are remain present? So this multiply with this divided by its molar mass. So the answer is 0.625 into 10 raised to 22 number of molecules present in 16 gram of solid sulfur. Our next question is calculate the number of aluminium ions present in 0.051 gram of aluminium oxide. So first we will find out the molecular weight of aluminium oxide. So what is aluminium oxide? Aluminium and oxygen. Aluminium's valency is 3, oxygen is 2. So by crisscross method we will get our molecular formula Al2O3. Now what will be the molecular weight? 2 into Al plus 3 into oxygen. Here we are going to write aluminium's atomic weight. So this is 27 plus 3 into atomic weight of oxygen is 16. So combinedly it is 102 gram. So this is molecular weight of aluminium oxide. Now next step, we have to find out the number of aluminium ion. Now one note has been given with this, that aluminium ion is equal to aluminium atom present in aluminium oxide. That means aluminium ions will be equal to how many aluminium atoms are there. Now whenever we are going to find out a number of atoms and number of molecules, then we have to find out through Avogadro's number. So that is 1 mole of any substance equals to its molar mass, then it is equal to 6.023 10 raised to 23 number of molecules for any substance. So here we are finding out for Al2O3. So this is our molecules. So 1 mole of aluminium oxide equals to its molar mass, that is we found out 102 gram. Then in that how many molecules are present? 6.023 10 raised to 23 molecules are there of Al2O3. Now we have this weight 0.051. So first we are going to find out how many molecules of this is present in this much weight, and then we will find out how many atoms are present in this much weight. So first we have this weight. So we are going to find out how many molecules are present in this much weight. So that is going to be 6.023 10 raised to 23 into 0.051 divided by 102. So that is equal to 3.011 10 raised to 20 molecules of Al2O3 are there in this much weight. 0.051 gram of Al2O3 consists of 3.011 10 raised to 23 molecules. Now we have to find out how many aluminium ions are present in this much molecules. So one molecule of Al2O3 has 2 aluminium ions. So simply we are multiplying these molecules with 2 because this represents molecules of Al2O3. Now in this how many aluminium ions are there? Then in one Al2O3 molecules there are 2. Then in this many 2 into 3.011 into 10 raised to 23 atoms, or what we have to find out here? Ion. Atoms or ions of aluminium are present in 0.051 gram of aluminium oxide. So that is all for today's video. Don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.